Okay, so today we'll be looking at Ethernet switching. So yesterday we looked at the data link layer and we looked at the role in which the data link layer plays, that it ensures node-to-node communication, node-to-node connection. So when we talk about nodes and we talk about end devices and all that, so irrespective of the media, maybe wireless or wired, so far you are connecting from a node to a particular node, data link layer is very, very important. And we also saw how the data link layer interface with the upper layers. We have the network layer directly above the data link layer. So the data link layer interface connects the upper layer and ensure that there's a connection between the two devices that need to communicate. So today we'll take it a bit further. We're looking at the internet switching, and when we talk about Ethernet, this includes the physical layer and the data link layer. So let's move on. So the things we'll be learning today, we're going to explain how Ethernet sublayers are related to the frame feeds. We're going to be describing the Ethernet MAC address. Yesterday we only talked about MAC address on the surface level, but today we'll be looking at the MAC address. We'll break it down. We'll explain the different section and how the MAC address can be easily identified when you say MAC address, and the role in which MAC address actually plays. Then we also look at, we explain how a switch builds its MAC address table and forward frame. When we talk about MAC address, by now, I believe we understand that MAC address is a physical address that is being assigned to every NIC, every network interface card, every NIC. So your system have an NIC, your phone has an NIC. Any device that can serve as a communicating device has an NIC. So we'll see how switch builds its MAC address table. When you look at a switch, you have a lot of ports on a switch. So each of those ports, they represent more like a location. They represent respective physical address. So how does a switch build up its MAC address? If maybe you stack two switches together now, when you stack two switches together, definitely they'll be operating as one. So how does one or the other build up its MAC address table? Then we'll also be looking at, we'll be describing the switch forwarding methods and the port setting available on layer 2 switch port. So Ethernet frames, that's the first thing we'll be talking about. So Ethernet encapsulation. So when we talk about Internet, like I said, it involves the data link layer and the physical layer. And yesterday we looked at the data link layer. We talked about the logical layer control, and we also look at the media access control. So we said that the logical layer control interface with the upper layer and ensure a proper delivery as it flows down from the top of the OSI layer. So it ensures that there's a proper delivery from the upper layer. Then we have the MAC, the media access control, which handles the encapsulation and error control. So now, anytime, please kindly take note, anytime you hear 802.2, 802.3 and all that, they are all talking about Ethernet standards. We talked about protocol. So all these protocols are being established by various regulatory bodies, like we discussed yesterday, the IEEE, the IETF, and so on. So all these bodies, they ensure standards are in place. So, but there are quite a number of them, so numerous. 802.802.2, 802.3, 802.3a, and all that. So those two family, when you hear them, just know they are talking about Ethernet. So Ethernet operates in the data link layer and the physical layer. So let's progress. So like I was saying, that for the data link sublayer, it has two sublayers. You have the LLC and the MAC, that's the media access control. The LLC places information in the frame to identify which network layer protocol is used for the frame. Now, like I said, that the LLC interface with the network layer, which is directly above the data link layer. Then the MAC sublayer rather, it is responsible for data encapsulation and network and media access control. Few classes ago, we talked about data unit. Let me go back a little bit. When we are at the network layer, the data unit when we are at the network layer is actually called a packet. It's a packet. But when it gets to the data link layer encapsulates it with some other information. Yesterday we said that it will add an header, it will add a trailer also. So in that header, there are a lot of ingredients. Let me put it that way. In that header, there are a lot of other details, not just one thing. Yeah, there are a lot of things involved, and also in the trailer also there are a lot of things involved. So when coming down from the top of the USI layer, at the network layer you have it as packet, but when you get to the data link layer, the data link layer encapsulates it with some other information which we will look at today. So the MAC sublayer handles the encapsulation, while the LLC interface with the network layer right above it. So what does it encapsulate? Like when we talk about that the MAC sublayer is responsible for data encapsulation and accessing the media, what does it do in particular? So the first thing is, like I said, when you get to the data link layer, you are no longer dealing with the data in form of packet. You are now dealing with the data in form of frame. Then another thing is the addressing. Now, at the network layer, what you have in that packet is the IP address of the source, the destination, and the IP address of the destination, and some other information. But when you get to the data link layer, you need to put in the source MAC address and the destination MAC address. So it's after this is being done that you can now say, okay, your data will be safely delivered to wherever you want it to be delivered to. Without the MAC address, there's no way in which your frame can identify where it's coming from and where it's going. So the MAC sublayer ensures that it's being framed properly. It adds the source and the destination MAC address. So kindly take note, the source and the destination MAC address is very different from the IP address. So I've talked about that the IP address is volatile, it can be changed and all that. You have the concept of DHCP and all that. But for the MAC address is very, very, very important. Without the MAC address, there's no way we can, without the digital link layer, there's no way you can affirm node-to-node connection. Then in addition, also the MAC sublayer also does the error detection. So in case the packet coming and all that, there's an error in the data, the MAC sublayer also undo this. So we will see as we progress, when we look at the feeds, we look at the various sections, the various components that we have in a frame, we have in an internet frame. We will see how the internet takes care of error. So let's progress. So still talking about the MAC sub layer, says includes execution of different Ethernet configuration, yeah. Then uses bus topology, or is a shared, okay. Yeah, yesterday we talked about how the internet, how the data link layer try to ensure that there is no collision. Most importantly, when you are working under half duplex. But as it is presently, people don't no longer do half duplex, do full duplex. Why would you want to do half duplex? I explained yesterday the concept of half duplex. When two persons are communicating, just picture it in that way. And while I'm talking, the other person can't talk. I have to wait, or the person have to wait for me to finish talking before he can talk. So that's half duplex. But when we talk about full duplex now, we can talk at both time, at the same time, and data will not be lost. So talk about full duplex. So when you have two communication devices, it can use half duplex or full duplex. So when you're using half duplex, then you have to talk about CSMA CD, how you are going to control collision. Yeah, how you're going to control who sends forth and all that to avoid collision and all that. So, but it's no longer really in play because we now do much more full duplex in many of the switches we have around us presently. So talking about the frame, now I was saying that when you collect the data, when the data comes down from the network layer, it's a packet. It's a packet. Then at the data link layer, some other details are being added. So that's what you are seeing presently. Now, the first thing that is being added is the preamble and SFD. The preamble and SFD is used for synchronization. It's used for synchronization. Then the destination MAC address, this is like the MAC address of where you want the data you've received from the network layer, where you want to direct to. Then the source MAC address is the MAC address of where the data is originating, like where the data is going, like where it's coming from, rather. Then the type and length, and it's giving us the type of the data we have, the length of the data we have. So that section is also carrying that particular information. Then the data itself, it's the PDU, the packet that we received from the network layer. Then the FCS is being used for error detection. So you have 8 bytes used for synchronization, 6 bytes for the MAC address. So we'll still look at MAC address. So when we're talking, a byte is equal to 8 bits. So when we're talking about MAC address, we know definitely that we're talking about 48 bits. So about 6 bytes is used for the destination MAC address, 6 bytes for the source MAC address, and 2 bytes for the describing the type and the length of the data, and between 45 to 1,500 bytes. The reason why this is varying is because you may decide to send a little data and decide to send, so that is subjective. So, but the minimum you can send is 45. And so there are some things that have been done. If it is not up to the size, there's what we call padding. It pads up the other empty space, pads it up. So, and the FCS is used for error detection. So like I was saying, so we have between 64 and 1,518 bytes within describing the range of the frame we can actually deal with when we are talking about frame. So it's coming down as minimum of, let's say it's coming down as 45, then it's leaving the data link layer at 64 because every other information has been added at the data link layer. So it frames the packet up with every of this other information I just mentioned. So now let's talk about MAC address. So we're going to be talking about MAC address in depth. So I just want to talking about, I say MAC address consists of 48 bits. And the previous class we talked about hexadecimal and all that. So we both agree and know that we use 4 bits to represent one hexadecimal. Hexadecimal varies from 0 to 15, but from 10 we replace it with A and all that. So, but if you are to convert this to binary form, you have it as 4 bits representing a hexadecimal rather. So now, if you try to now break this down, that means you have 12 hexadecimal values. So even if you try to convert what you have 12 hexadecimal values. So let me now give us an example of how a MAC address look like. So before we do that, let's briefly look at the constituent. You know, I said we have it to be 12 hexadecimal. You have to be 12 hexadecimal, but the first 6 is the organizational unique identifier. Now, the way the MAC address is if you want to maybe build a product today, and you want to start assigning MAC address to the product you build, maybe you build a communicating device, you have to get an organizational unique identifier. So that's the first 6 hexadecimal, I mean the first 3 bytes, what it's meant for. So you have to register, then you have to get your OUI, then the remaining 6 you can now decide to vary it. So the reason why this is important is we've said that we can't afford to have MAC address having the same address. There's going to be a problem. It needs to be unique. It needs to be unique. And that's why you can't just easily change it. Although there are systems lately on how you can maneuver around your MAC address and all that. But the first 6, so you can't just wake up and give yourself MAC address. Just like you can wake up and give your device a private IP address. You can't just wake up and give yourself MAC address. So it needs to be registered. It needs to be registered. And there are a lot of different ways that people randomly generate fake MAC address for whatever purpose and all that. But for it to be identified globally, you need to get an OUI. Then the remaining 6 hexadecimal going to be assigned by you. Going to be assigned by you. It's left to you to assign that. So let's keep in mind we have 48 bits for our MAC address, 6 hexadecimal for the OUI, 6 depending on whatever way you want to. So let's look at frame processing. Let's do that. So when a device is forwarding a message to an internet network, the internet header includes source MAC address and destination MAC address that I've explained. So when it's coming down from the network layer, what the data link layer does is it encapsulates it. Yeah, it encapsulates it with the source MAC address and the destination MAC address. So when an NIC receives an internet frame, it examines the destination MAC address to see if it matches the physical MAC address that is stored in RAM. And if there is no match, the device discards the frame. And if there is a match, it passes the frame up the OSI layer where the de-encapsulation process takes place. At this point, I want to pause and to be sure that you guys are following me. Do you understand what I've been explaining so far? I appreciate your response, please. Do you understand what I've been explaining so far? I'm not hearing you guys. Start on names. I know we are 3 in this class.
I can hear you, sir.
Okay. Okay. So I progress. So do we understand? You said yes, sir. Okay. Can somebody just briefly share with me what is new that you've just learned lately from the past few minutes I've been talking? What new thing do you think I just learned this one?
Personally, I just joined and we were speaking about frame processing. I just joined from second today.
Okay.
Talking about frame and processing.
Okay. Tumiche, can you share with us one new thing you think you've just learned from all I've been saying?
Can you hear me now?
Yes, I can.
Okay. We talked about Ethernet. You said it's a family of networking technologies, and anywhere we see 802.2, 802.3, the under Ethernet. They also said that they can be separated into two sublayers. They measured, I think, LLC, I measured MAC. Then we talked about the Ethernet frame. I think, can you hear me, sir?
Yes, I'm enjoying you.
Okay, and then we talk about the Ethernet frame. Then we also talked about the Ethernet addressing. That's all I can say.
Yeah, thank you very much for following. I appreciate that. So I will progress from there. So talking about frame processing. Now just picture it. Just picture it. I want to send something to you. How is it that the system just agrees and just believes that, okay, I actually, like, how does it happen? It's because in what I want to send, I've put your address on it, the destination address. So when it gets to you, you check the receiver, like the receiving, check that, oh, the destination address, the MAC address, destination MAC address, does it belong to me? If it belongs to me, then I will de-encapsulate it. I will remove all the details that have been added by the data link layer of where it's coming from. Then I will get the data that's actually needed. But if it's not meant for me, when I check the destination address, not meant for me, I don't de-encapsulate it. So it's the responsibility of whoever is meant for that de-encapsulate it. And that was how, if I send something, maybe through a switch, direct, okay, maybe take for instance, like I'm sending a message to you. That's communication. I'm sending a message to you. I put your phone number. I'm testing you. I put your phone number and all that. And when I send the message, it gets to you. It does not get to maybe my pastor, or it does not get to my friends or someone else. It gets directly to you. What has happened? It's because the message have encapsulated, your address have been encapsulated to, so nobody opens it up. Nobody sees it except the address on it. So that's how frame is being processed. So from where it's coming from, it has been encapsulated with the destination address and the source address. So when I check and I realize it matches my MAC address, then I de-encapsulate it, I open it up, just like a message being sent. So that's how frame is actually being processed. So let's progress. So now there are different MAC addresses. There are different MAC addresses for, like, and I mean the ways at which you can communicate when it comes to MAC address. For layer 2, layer 2 unicast, you have the broadcast, when you have multicast. When you're talking about unicast, you are sending directly to a particular person. You are sending directly just to one receiver. Then when you're talking about broadcast, you are sending to everybody on that medium, on that network. That network, you want everybody to have access to that. That's what I mean by broadcast. But you maybe multicast, you want to be received by only a few set of people. So take for instance, I send a message, like I've always said, maybe from the Senate to School of Engineering, and that's a multicast. Let's say maybe from the VC office sends ID to the HOD, that's a unicast. Then maybe the VC sends to everybody in the school, that's a broadcast. So, and there's a way the system goes about doing this. Then definitely we know that the source MAC address must always be a unicast. I mean, the person sending it must be one person. Like 5 person can send to 5 person, and it's not possible. So the source is definitely a unicast. Then the process that a source also uses to determine the destination MAC address with an IP address is known as address resolution protocol. We'll still look at all this later on. But if you're talking about IP version 6, it uses the neighbor discovery. So we'll still look at all this before the end of this program. Then the broadcast, like I've said, So when you have the MAC address with FFFFFF, that means, oh, this is a broadcast message. Send this to everybody. Everybody receives it. So when the destination MAC address is carrying this, it's for everybody. It's broadcast. Yeah, that's what it means. Then multicast, when you are sending to a particular set of people. So you can see on the screen, I'm only sending to those that were thick green, and not sending to those that were thick red. So, and there are the various protocols that guide all this. So the MAC address table, how does it get filled up? How does it get tabled and all that? So the layer 2 internet switch uses layer 2 MAC addresses to make forwarding decisions. It's completely unaware of the data being carried. We all agree to that. It does not unpack it. It's not its responsibility to look into the data. It's not the one processing the data as it is. That's not what it does. It does not do that. So the switch makes its forwarding based solely on the layer 2 MAC address. Yes, we've learned that. Then the internet switch examines its MAC address table to make a forwarding decision. So if let's say for instance now, okay, maybe when we have a practical, you will see a switch. For those that are familiar with a switch, so imagine you have a lot of end users on a switch, and like maybe you have 10 systems connected to a switch and all that. But I want to send to a particular switch. So when I send my frame, when the frame is being sent, now it's being broadcasted to look at the MAC address table. Is it on my MAC address table? Do I have it on my MAC address table? If it has it on its MAC address table, then look for the port that has that MAC address, then it delivers that frame to that particular port. But if it does not, I'm talking about a switch now. If it's not on its MAC address table, we look at it, then it will send it to everybody to see who has it to and all that. So then also there's a way the switch tries to update its MAC address table, because it may change the MAC address table. So after some time, it updates it. Just like when I'm talking about table, just like a table like already reserved in the switch memory. Sorry if this section finishes soon. Endeavor to log in back because time is running out. The Zoom time limit. So I just finished explaining the switch fundamentals, how it uses the MAC address table to forward frame. Yeah, I use the MAC address table to forward frame, and this MAC address table can, just like every frame that enters a switch is checked for new information to learn. Now, this is how the MAC address table learns, how it updates its MAC address table. It does this by examining the source MAC address of the frame and the port number where the frame entered the switch. If the source MAC address does not exist, it is added to the table along with the incoming port number. If the source MAC address does exist, the switch updates the refresh timer for that entry. So if it's not on the table and it realizes the destination MAC address and all that, it adds it to its table. Then how does it forward? If a destination MAC address is a unicast, that means you send it to a particular person, the switch will look for a match between the destination MAC address of the frame and an entry in its MAC address table. If the destination MAC address is in its table, it will forward the frame out the specified port. So that's if it is on the table. If the destination MAC address is not in the table, the switch will forward the frame out all ports except the incoming port. And this is called an unknown unicast. So if it's not on its table, it will send it to everybody and see. If the top gets here, just pick it. Whatever I just picked it and all that. So that's how it forwards and frame using destination, using MAC address. Then featuring frame, this we just talked about. As you receive frame from different devices, able to populate its MAC address table by examining the source MAC address for every frame. When the MAC address table of the switch contains the destination MAC address, it's able to filter the frame and forward out on a single port. So I think that have been explained. So switch speed and forwarding method. So how does it go about the forwarding method? You know, we've talked about how, okay, it will know where it should forward it, where it should be forwarded to. So, but in what manner does it forward? So it uses two methods actually. So that is in the store and forward switching or cut through switching. If it's using the store forward switching, that means it will receive all the entire frame. Maybe I send hallelujah, praise the Lord. It will receive everything as a whole. They will compute the CRC. The CRC is cyclic redundancy check. So it's going to check if there's error there. So if the CRC is valid, that means there's no error, then to now completely forward. So we allow the entire frame to come through before it calculates the CRC. But when you are using the cut through switching method, as the frame is entering, it won't allow everything to gather. It won't allow the entire frame to gather. It will, as it's coming in and it's receiving it, it's reading it and it's forwarding it immediately. It's reading it and it's forwarding it immediately. So, and there's a big advantage to the store and forward switching because it helps us save bandwidth. Because imagine I'm collecting, I'm sending immediately, and at the end of the day, I realize there's error and all that. I've wasted that bandwidth. But if I collect and I calculate the error before I forward it, then I've actually saved bandwidth. So that's one of the advantages of store and forward switching. Then store and forward switching can be in two ways, that the fast forward switching or the fragment free switching. So if it is the fast forward switching, just like we said, the entire packet is connected. There may be times when the will be relayed with error, this and that. I think it's the fragment. The fast forward further just define what the store and forward switching does. Actually, what the cut through does entirely. Immediately forward, yes, what it does. But what the fragment free, so it's just a compromise between, this is a compromise between the cut through and the store forward. Because what it does is the switch stores and performs an error check on the first 64 bits. So rather than sending it immediately as it's receiving it and all that, it waits for collects about 64, computes the error, then forward. So it's just like standing between the cut through switching and the store forward switching. So then we also have memory buffering on switch. Like maybe I'm trying to send to you and the port is busy at that time. Where would the data be saved for the time and all that? So, and also is either port-based memory or shared memory to hold on a data when you are sending it to a port and the port is actually busy. So how do you undo the data being sent? How do you put it on a hold? So you're either using the port-based memory or the shared memory. So the shared memory is being shared, it's made available to all the ports. Yes, it's made available to all the ports. The port-based memory is just specific to the port alone. Then I've talked about full duplex and duplex. Then the concept of duplex. So if it's full duplex, we cannot talk to each other at the same time. But if it is half duplex, so the half duplex is no longer really in vogue again. Yeah, it's no longer really in vogue again. And even as it is, you don't even have to automatically set your maybe like, and the thing is just that for two devices to communicate, actually, they must synchronize. That means where you are sending from and what you are receiving must have the same machine. I'm full duplex, you're also full duplex. That's when we can communicate. If I'm full duplex and you are half duplex, we can't communicate effectively. So, and are we going to be manually just setting this and all that? So, auto MDIS came into place. That means when I connect a new device to it, it automatically synchronizes. And if I'm full duplex, it sets the other devices to full duplex also. And also when I also talked about I think I also talked about and I talked about cable. When I talk about cross cabling and straight through cabling, yeah. So when I was saying that when I'm collecting DC to DC, we should use a cross cabling, and when I'm collecting DC to DT or DC to DT to DC, we should use a straight through cable. But I now said that lately there's an automation set in place that it automatically, even when you use a straight cable, it still allows you connect maybe DC to DC, DT to DT. So the auto MDIS fixture, it's now made available on many of the routing devices and communication devices that we have. So that marks the end of our class for today. I don't know if we have any question. We have any question from anyone? Any question? Okpe, any question? Temitokpe, any question? Tumishe, any question? From all I've said in today's class. Any question, guys? Any question?
You can go ahead, sir. I don't have question for now, sir.
Okay, so that marks the end of this class. So ensure to do your exam before on the 2nd. That's from 4 to 7 module. Ensure you do your exam. And if you are not clear with anything, please.
On the 2nd, sir. On
yes,
the 2nd,
yes, before on the 2nd, yes. Before 2nd of February. Before 2nd of February. So thank you very much. I will upload the recordings of this class to YouTube as promised. So continue to study. By next week, we'll continue with module 8. Thank you very much, and do have a wonderful weekend.
Thank you, sir.